Hi, I'm Emily, the MajorTim.space Young Ambassador Program Mentor.
Hi, I'm Raghavendra, the MajorTim.space 2022 to 2023 STEM for Her Young Ambassador.
And today we'll be interviewing Pete Lomas. Would you like to introduce yourself?
Sure. My name's Pete Lomas. I think the thing I'm most known for is the designer of the very first Raspberry Pi. And I've spent over 10 years now working with children and the Raspberry Pi Foundation to get people interested in coding, digital making, and everything electronic. As that's sort of my non-day job, but my day job is designing and building electronics for companies across the globe. And we can talk about that a little bit later. So hi, Emily and Eva. Look forward to having a good chat with you.
Yeah. So kind of my first question that I would like to ask is why is the Raspberry Pi so kind of compact and small? And also, was there any kind of design challenges that you faced? Or like, was it kind of difficult size?
Emily, you're just breaking up a little bit there, but I think I caught the gist of that.
Okay.
Yeah, so I mean, Raspberry Pi came about because we were all sat in a room in Cambridge University and we were discussing the idea of building this really small computer. And the conversation sort of got to, well, how small should we make it? Because actually computers can be very small. I mean, because you've got very small computers inside things like your phones. And so I just pulled out a credit card and said, what about this size? So actually, if you take a Raspberry Pi and you actually measure it, it's almost the size of a credit card. I never managed to live down the fact that it's not exactly the size of a credit card. And if you look at the very first one, it had square corners, but James Adams, and we can talk about that later, said, well, no, credit cards have got curved corners, so we should have curved corners. So on the next generation of Raspberry Pi, it had curved corners. Now, the whole thing, why it's so small and why it can be so small is because the processor of the Raspberry Pi is actually just a single chip. On the very first one, which I've actually got here, let me just hold it up to the camera. Then all of the real processing goes on in this single chip here in the middle. All the rest of it is about getting the signals out for things like keyboards, displays, and the thing that we call the GPIO, which allows you to actually connect all sorts of interesting things to a Raspberry Pi. And that's what made it so special.
I would also like to ask, was there any kind of difficulties in making it so small, even though it's like only like the most important part is only the chip, which is quite small anyway? Was there any of those like kind of things that makes it difficult to fit everything onto just the size of a credit card?
No, it wasn't so much fitting things onto the size of the credit card. The challenge was that Eben, when we launched our website in 2011, said they're going to be $35. And the real challenge was to build it for $35. And one of the real problems is all the parts are basically held together. The glue of a electronic design is the circuit board that goes on it. So, you know, this green thing that we talk about. And the big challenge was really trying to get all the signals out of the control chip to all the peripherals in the cheapest way possible. And that took us quite a while to figure out how to do it. But no, I mean, generally it was fairly straightforward, although a little bit hair raising because we got the first prototypes just before Christmas in 2011. I plugged the first one in and nothing happened. So I got the second one thinking, oh, it's just I plugged the second one in, nothing happened. Plug the third one in, nothing happened. Plug the fourth one in, nothing happened.
Oh.
You know, this is where you start to sweat a lot, thinking, oh, have I made a terrible mistake? And it turned out that we'd made one simple error on the schematics that meant that one part of the chip wasn't powered properly. Anyway, it was a really simple fix. We just had to scrape some of the green off the board to expose the copper, solder two things together, and then they burst into life, and they all worked, fortunately. But that was a little bit of a hair-raising moment.
Eva, do you have a question that you'd like to ask?
So what inspired you to get into the engineering field?
Sorry, could you repeat? I just got a little bit of distortion there, Eva. Sorry.
What inspired you to get into the engineering field?
All right. Yes. So it's a terrible admission, but I hated school. I really didn't. And I think that my problem with school was that I never knew why they were teaching me the things that they did. So I used to tinker in my bedroom with electronics. Now, this is back, right? I'm going to expose how old I am. I was 13 and the year was 1968. So don't go and figure that out, okay? Because it makes me... But electronics and things that we were doing in those days meant that you had to use things like this. And so I ended up buying half a telephone exchange at a junk shop and turning it into a noughts and crosses machine. So it would play noughts and crosses with you, which now you'd think, oh, that's dead easy to do on the computer. But we didn't have computers then. I mean, computers were massive things in big office blocks. And so you didn't have access. So I didn't realize it, but I'd actually built a computer that did one thing, which is play noughts and crosses. So that was, I was always interested in making things. And so that was sort of the first start in engineering. And it's like I say, I really didn't get along with school. But then I left school at 16 and went to a technical college. And at that technical college, they had all sorts of bits of equipment that you could actually work with and do experiments on. But most importantly, they had a computer. People can you can look it up on Wikipedia and things in the sort of ancient history department of Wikipedia. It's called a PDP-8. It was a very simple computer and it ran a thing called BASIC. So I was at the at the tech college and went into the room where it was and thought, oh, well, that's interesting. What's that? And there was a guy there who actually looked after it. And he said, oh, what course are you on? I said, oh, I'm on OND, then HND electronics. And he said, well, this is for the degree students, so you're not allowed to use it. And I sort of turned around a bit miserable because I thought, that's not much fun. And he just whispered in my ear, but you could always come back at lunchtime. And then for 2 years of lunchtime, I went back and played with this computer and wrote programs on it, got myself into a little bit of bother now and again. But I remember the first time I went back, I was quite nervous. Now, the computers in those days had something that's akin to a typewriter, or they call it a teletype. I don't know whether you've ever seen one.
Wait, a typewriter, yeah.
So what happens is, so you type things to the computer on like a typewriter, and then it comes back and types things on your paper as the response.
Yeah.
So you're not working on a screen, and the stuff isn't just going up a screen; it's actually coming up on physical paper. So he says, right, well, we need to write a program, and the language is BASIC. So you can imagine what was coming there. It's like 10 print hello world, and then 20 go to 10. Then he says to make it go, you type run. So you do that. And then, of course, what starts happening is it starts printing up the page. And it just keeps going and keeps going and going and going because I've not told it to stop. So I said, how do I stop this? And of course, you had to know the magic runes of it, which was Control C, and that would stop it. But I didn't. So I tried stop, halt, go away, give up. None of it worked. It just made a little bit of a mess of the typing. And then he just leans over and goes, Control C. And he said, this is the most important lesson that you're ever going to learn. That is, with computers, if you don't know, there's almost no way of finding out unless you ask somebody. So there's nothing that's actually ever a stupid question. It's only a stupid answer. And of course, that's absolutely true about everything in life. So then I asked lots of questions like, how do I get it to do this? How do I get it to do that? And then the engineer that came to service it came, and I was able to sit and watch, and I just got fascinated by the way that computers were built. And in fact, by the end of the 2 years when it broke, they used to pull me out of a lecture and say, can you come and fix the computer because you know what you're doing? So I used to go back and actually fix the computer for them. And so then, I mean, that was my interest. I was absolutely fascinated by computers. And that was how I got into engineering, because I was actually fascinated not with necessarily using them, but how you build them. I mean, having gone back to my noughts and crosses machine, how do you build computers? How do you design a computer? So I managed to get into Manchester University and then learn all about computers there.
My next question's kind of like related to that, but like also not really related to Raspberry Pis, but it's kind of like, do you think that maybe from a young age we should start teaching children about computer literacy and like programming? Do you think that'll like soon become quite like a not valuable, but like kind of like a necessary skill for young people?
Definitely. I think people sometimes get the wrong idea about computers. To me, it's a tool. In the same way that if you were building a wooden boat, then your hammer and nails and a plane would be the tools to make it. If you think about it, it allows you to do things. If you can think of you can think of the algorithm that you want to do, then the computer can do it for you. So it allows you to do more. So it's definitely a tool. I mean, obviously now with AI, then things have got a little bit more interesting and a little bit more complex maybe. And it's not always possible to exactly figure out what the computer's doing. But in general terms, yeah, absolutely. You should be learning about how to use a computer for other things that you want to do, to analyze data, to collect data, to collect images. I mean, even if you're in the wildlife, you know, using a Raspberry Pi in a kit, you can actually detect things moving and then take pictures of it. And so using the computers to do all these different things is a valuable skill to have. It doesn't mean you have to be a computer person. That's, you know, oh, I'm into computers. You can be into any sort of science, engineering, or any technology, or even, you know, in nature conservancy, and the computer would be useful to you. So very simply, the answer is yes.
Eva.
Do you have any interesting story or nice memories from the days when you were working on Raspberry Pi hardware?
Oh well, yeah. I mean, I told you about the sort of heart-stopping moment when the first ones didn't work. Yeah. So we had quite a few heart-stopping moments all the way through. And one of the famous ones is we actually launched Raspberry Pi at the end of February, and it happened to be a year where it was a leap year. And so 29th of February, we went to launch, and we thought, oh, it might be interesting. and we managed to crash 2 commercial websites and our own website through so many people trying to order the Raspberry Pi. And because I work in electronics, I had all the people who purchase electronics came in my office and stormed in and said, "What have you done? You've broken the internet and we can't order parts." It was sorted out after a few hours, but it was a bit of a, oh, this is going to be a bit of a problem. Because what happened, people tried to buy it on one site, then tried to buy it on the other site, and then tried to ask us on the Raspberry Pi site why they couldn't buy it. So it was just absolute chaos. And I think in Brazil they called it a computer frenzy in their headline in their electronics newspaper for people trying to get Raspberry Pis. And of course, it's been like that a little bit all the way through now. We've now sold, literally millions of them. But that was a little bit of an exciting moment, as when we also ordered, I think 20,000, and the first ones turned up. I mean, you've got to understand, we were a charity. There was 6 people. We had no office. We had no people working full time for us at that point. And we were sat there and we get a call from Jack, one of the founders, saying, "This pallet of Raspberry Pis has just appeared on my drive. Somebody's just dropped them all off." And so we had to send a team of people down there to hoof them into his garage. So the first Raspberry Pis came on a pallet from China and actually ended up in his garage. And it was a good job it wasn't raining. That could have been quite embarrassing.
Yeah.
But yeah, we've had some fun. We've had some show-stopping moments where we found that one of our Raspberry Pis was camera shy. If you tried to take a flash photograph of it, then it would stop.
Wait, what? So how did that happen?
Well, what people don't necessarily realize is electronic components are sensitive to light. When I was a young kid, we used to make photo transistors by taking the transistors out of their can, and then you could actually, if you shone light on them, then they conduct. So you could use them as a photo cell. Now, modern electronics is pretty much the same. If you shine a really bright light on it, you can cause it to disrupt what it's doing because it acts as a photo cell. And we had one chip on the board which was actually, rather than being in a package, it was turned upside down. It's called a flip chip. And it was, what happened is the light from the flash was getting inside the chip and disrupting it just enough to stop the Raspberry Pi working. But rather than getting all sort of very secretive about it, like when people have problems, we actually published a full sort of spread on the physics of why they stop. And all you had to do, if you really were worried about that, you could just get a piece of blue tack and stick it over the top of the chip and everything would be fine. But it was only if you had really bright, if you're doing a flash photography of a Pi. So that was our camera shy Pi. But no, I mean, generally, the only other really heart-stopping moment that we had was when we were trying to get the Raspberry Pis to the ISS. So Tim Peake was going in December, but the actual Raspberry Pis were going to go a little bit earlier on a cargo mission. And the weather wasn't very good. And so I think the first night it was scrubbed. The second night it was scrubbed. And then if it hadn't gone the third night, then obviously the third day in America, then that would have been it. There would have been no Raspberry Pis on the International Space Station, and all the work that Tim Peake was going to do would have failed. And in fact, this is what we had to get up to the International Space Station. This is a replica of the ones that Tim took. Obviously, it's a little bit bigger than a Raspberry Pi because it has to protect the astronauts. It also has a little sort of connector here, because the problem is if you don't sort of clamp it down, it's going to float away. And where's that Raspberry Pi gone? And also the enclosure also helps with heat dissipation, because what I didn't realize is in space heat doesn't rise. Which way's up in space? So it's quite fascinating. So that was a bit of a moment, but no, it got away and they got to the International Space Station in time, and Tim was able to use them on his mission.
I had taken part in the European AstroPi Challenge Mission Zero competition. For the competition, I had to write a little program that was run on the Raspberry Pi computers on the International Space Station. The program was to show a message to the astronauts and show the humidity.
Right, to show the humidity of the around the AstroPi, and then you could possibly detect that the astronauts were getting close, because the humidity goes up very slightly when they get close. No, that's good. I mean, it's amazing, really, because they are the fastest Raspberry Pis we've got, really, because they're traveling at what is it? I just get this right. It's about 17,000 miles per hour as they go around the Earth. At about, I think I always get the units all mixed up, because I think it's 7.66 kilometers per second is the speed of the ISS, something like that. I mean, that's really quick. But of course, it'd fall out of orbit if it was going any slower, so that's probably not a good thing. And but one of the you were talking about other things about Raspberry Pi. Very early on, we had one that was launched on the bottom of a weather balloon with a camera, and that managed to get up to about 40 kilometers above the Earth. And you can actually, at that height, you can actually see the radius and the curvature of the Earth quite clearly. You can also see that the sky above is black rather than blue. And that then led to an embarrassing question of, well, why is the sky blue? And that's just another piece of physics, yeah? The Rayleigh scattering in the atmosphere that causes it to be blue. So I think the one thing that I really love about the things that we've done with Raspberry Pi is it branches out into all sorts of different interesting things that I never knew. And it's it's been really interesting, especially if you're just interested in science in general and engineering. But I didn't become a scientist because I like making things. That's why I became an engineer. I like creating things, making things happen. And at my company, we also say it's about bringing ideas to life. Yeah. So that's what we do, and we've been very lucky. We've worked with lots of people over the years, and of course, Raspberry Pi has been particularly special for me. So,
in your day-to-day job, do you ever like work with the Raspberry Pi or use the Raspberry Pi to do that?
Oh yes, I mean it'd probably be a bit, it'd probably be a bit weird that somebody who designed it then didn't use it. I have to confess, I'm not a brilliant programmer, right? I've got other people who are good programmers. So you can be relieved. Engineers are not necessarily the best programmers. I can get by, I can do what I need to do, but I leave the programming to the experts who that's the direction that they've chosen to do. But you want to interface something to a Raspberry Pi, then I'm the man. Yeah. And we were very fortunate because you can, the connectors that you can see. In fact, I've got a latest one here. So this row of connectors at the top here allows you to connect all sorts of different things. You can start off with just an LED and a switch or a little ultrasonic sensor or you can plug all sorts of complicated things on the top that other people have made. So the really important thing is that if you have an idea, you can probably get the bits to try and make it work. And that's why Raspberry Pi is more about engineering and building things rather than sitting at the computer typing things and watching, playing games on it. It's more about making physical things that will monitor or control things. And that's why people make a lot of robots with Raspberry Pi, because it's almost perfect for that. And as a sort of in the intro, my rather embarrassing robot, which the wheel has just fallen off.
Oh.
But hey, never mind. I mean, this is what happens. This was a sort of challenge that we had with a company. We said, okay, well, we'll get everybody together. The challenge will be to make a robot that follows a particular course. And of course, they then said, oh, you're going to have to do it as well, and you're going to have to program it. So doing the hardware was easy. Figuring out the programming, not so much. But I got there, and I did manage, fortunately, to beat everybody, and I got the fastest lap time, which was a bit of a moment because I should have done, having created it. Well, I was never quite right with the wheels. I'll try and figure out how to put that back on later.
Eva, do you have a question?
So can you tell us some of the coding clubs run by Raspberry Pi Foundation?
Yes, so one of the things we wanted to do was actually engage, children and also adults. And so we produced a lot of how-to guides that you'll find on the website that introduce projects that teach you about various aspects of coding. But I think the most important thing that we did is there were two organizations. There was Code Club and Coder Dojo, which were both encouraging young people to get involved in coding of various types, whether it was building HTML pages or for the internet, or whether it was actually writing things in Python, for example. And they came in with us, and it's been hugely successful in that they've got lots of clubs running both in the UK and abroad that are allowing young people to get involved with coding and understand what it's about. Again, to understand, like we talked about earlier, about using the computer as a tool to do other things potentially. So that's been a huge push. And the other thing that we've done, of course, is to try to influence the curriculum in schools about teaching about computers and coding and programming, as we call it. Then, so there's been a lot of activity within the foundation for that. I don't know whether either of you have ever come across Code Club or Coder Dojo.
In primary school, I was part of a project that used Raspberry Pis to come up with like a solution for a sort of problem.
Right.
And we built like a joint brace that kind of alerted the people of when kind of it was like bent past a kind of safe limit.
Right. Very good. Did it work?
It did.
Excellent.
But it didn't go through. It was like a competition kind of thing, and it didn't go through.
Ah, right. That's the problem with competition. There is so much competition, but never be downhearted. Just keep plugging away, and eventually you get there.
One thing I wanted to ask about was how engineering and like kind of robotics because it's like being taught to the younger generation, it's also quite important about like finding ways to also preserve like our future. So how we can use robotics to kind of help preserve our environment. and kind of protect nature, you know?
Yeah, it's interesting. So I see quite a lot of projects through the Royal Academy of Engineering where people are looking at things like farming robots. And the other one I really like was a weeding robot. So rather than having to put chemicals down, it was actually weeding by using artificial intelligence to detect the difference between the plants you want and the plants you don't want. I mean, I have to say, I'm rubbish in a garden. I can't tell the difference between a weed and something that's supposed to be there. So, but obviously, this could, and in fields that it was involved in, it could go through and weed and basically weed them. And I think the other thing that we'll get involved with is using computers to control hydroponics to allow us to do vertical farming, which means less of the surface area of the planet will be involved in actually growing food, which you would hope would encourage people not to keep demolishing large amounts of rainforest and to put soy or other bean products in and farming. I mean, there was a thing this week in the news about trying to preserve 30% of each country's land mass and water mass for marine rejuvenation. And I think that's all really interesting. I think robotics has the potential to help in so many ways. In one way to collect data, and in other ways to actually improve people's lives. I mean, we talk now about, you've seen things called an exoskeleton that will help people who can't walk, and they would be able to be mobile again. But in terms of the environment, maybe not robots per se, but computers and systems built on computers to monitor things like pollution is a great way. If you don't have data, it's hard to know whether you're improving things. I mean, obviously computers and AI have been doing lots of things in trying to understand how you might modify DNA and actually help save lives, or even create new chemicals that will help. I mean, obviously there's a worry there they might do something a little bit off piece that we're not really happy with, but the potential is there to do things that can help the environment. But what it needs is people like you to get involved and become engineers and say, I am going to work on these projects to solve these real world environmental challenges.
What do you feel about the success of Raspberry Pi? When you first started working on it, did you ever think it would grow into such a global occurrence?
Right. So, might be slightly embarrassing this, but I was sat in a room in Cambridge and we said, how many Raspberry Pis do we think that we'll need? And we went around the room, and I think the ultimate result was we'll probably need about 3,000 ever. I said, well, that's fine. You send me the chips and I'll build 3,000 for you through my day job. So it was a little bit embarrassing when we first asked people who would be interested in Raspberry Pi, and we were quite shocked because 200,000 people said that they were interested. And then when we started to sell them in the first sort of 18 months, we'd sold over 1 million, and it's just gone crazy. But I have to admit, we had never had any idea when we first started that it would take off the way it has. One of the things that did that was the community that's built up around Raspberry Pi, the people who got involved early days because they understood our mission, they understood what we were trying to do, what this little computer was about. And they came in and they wrote resources, they wrote all sorts of things to actually help us get things off the ground. And I did lots of interviews and presentations to try and encourage people to get involved and actually use Raspberry Pi. But we had no idea back then. Probably we had no idea. We just kept looking at the numbers and it just kept going up and up and up. And the request for the computer was getting more and more and more. So it's been hugely successful, and it's really hard to put one thing that's caused it to be that successful. But I think the community was hugely important, and I'll always be in their debt for actually getting involved, because the whole object of Raspberry Pi was to turn people from being consumers that sat there with their Xboxes and so you got like an Xbox or a Wii or something, and you just sit there and you play games. What we wanted is to break that and say, no, why don't you write something yourself? Why don't you take control and design and build something of your own? So it turns you from being a consumer of content, of games, into somebody. Even if you create games, you become a creator, because creativity is something that the human race is actually very, very good at. We're also quite good at just consuming content as well.
Yeah.
Yeah.
I think it's very good that, like, kind of to encourage people from such a young age to not just kind of just go along with the flow and consume things, but instead to like take more control and from like such a young age.
And also to be able to start to understand how things work. It's always better if you understand how the things around you work, because you'll see opportunity for using them in a different way then.
What was the inspiration behind the name Raspberry Pi and the Raspberry logo?
Ah, right. It's quite a common question, this. So the official answer is everything successful seems to have been named after a fruit. Yeah. So apple, obviously.
Like apple. Yeah.
Yeah, exactly. But we were I suppose we were a little bit scathing about the closed ecosystem of an Apple phone or an iPad. And somebody made a comment that, oh, if we can get this off the ground, that would blow a raspberry at Apple. And somebody said, that's a good name. And also it's a bit funky as well. I wasn't quite so sure that calling a computer or even calling a charitable foundation Raspberry Pi was going to fly. But it did. And the way that the logo came up was that we ran a competition. Yeah. And we said, we want you to design a logo for us. And a designer from Sheffield called Graham Beach came up with this inspired raspberry logo that's really quite simple. But he told us that the actual design of the base part of the Raspberry Pi was based on buckyballs, and I had to go and look that up on the internet to figure out what it was. But it's been brilliant. It's really an important thing in the sort of development of Raspberry Pi, is this very recognizable logo.
It's quite iconic.
It is, and I hope it's interesting if I walk around with I have a little rucksack with a Raspberry Pi logo on it. Sometimes I get stopped and say, "Oh, is that a Raspberry Pi logo?" And I go, "Yeah."
Wait, do you guys also sell? This is a bit off topic, but do you guys sell like other Raspberry Pi logo merch?
Oh yeah, there's quite a lot of merch flying around that's
Oh, I want it.
Raspberry Pi. But I mean, I prefer just giving away the stickers and encourage people to stick them on the laptop over. You know, if they've got an Asus laptop or something, just stick it over that. And we also have these little things saying my other computer is a Raspberry Pi. Yeah. But yeah, we have there's a few things. I've got a Raspberry Pi mug which seemed to have got lost. Somebody's purloined it, and we should be able to find it easily. But yeah, we've got a few things. I mean, right in the early days, we actually sold really small sets of stickers to try and generate some revenue, because we had no revenue as a small charitable foundation. And that worked quite well. I don't think Liz wasn't too happy because she had to post them out. So that was a really massive effort. And in fact, thinking back, I think if she'd had the money, she'd have paid us not to send them out. Yeah, with the amount of pain. But it's what happens with a startup. You do things because you just have to do it to get over that hump. And it's a bit like you sort of your journey in coding. It's a journey, it's a road, and it just goes on forever. But the great thing about Raspberry Pi and the community is if you get to this really steep bit that you think, I can't get up here, I'm just never going to be able to do this, there are people that are there to help you, and people that will contribute and help you get over those hurdles. And then when you get to the top, of course, you can coast down the other side for a while. So again, like I've said, you know, having a group of people is always easier.
One question I want to ask for anyone that is watching this is, do you have any recommendations for beginner Raspberry Pi projects for people to start off with? Because, like, for me, for example, other than like doing that one thing in primary school, I don't have any experience. It's quite a bit intimidating to not know where to start with it.
It is. So in computer programming, where I started with print hello world. Yeah. So you could actually start with that, something as simple as that. And it's all the bits that go around it, you know. Okay, so how do I make this do it? Where does the output go? And all those bits around it. And if you translate that into sort of electronics, then the answer is an LED. The first thing is to get it to light. The second thing is get it to flash. The next thing is to get it flash Morse code. The next thing, yeah, you can put 3 of them in and make it into a set of traffic lights. So you can start with something really, really simple and then build out a little bit at a time till you've got something potentially quite complex. And if you're programming and you're just unsure about starting with programming itself, you could start with something like Scratch, which is the nice thing about Scratch is that all the things that you want to do are sort of already there on the screen. So it's like a big hint. There's like a hint down the side that says, you know, here are all the things you can do, and this is how you can make the sprites do things. And that's great as well. And once you feel confident about that, then you can translate over into Python or some other programming language to actually. I think a lot of it is this fear of getting started and not knowing the answers. And this is what I said before. The problem you have is that if you don't know, you don't know. So you have to do a bit of research or have somebody with you just to help you move forward with your project. And if you get stuck, don't be afraid to ask for a bit of help. So that's where I start. And then we've got, when you've gone from there's hundreds of projects on the Raspberry Pi site that you could try. Some of them need a little bit of electronics, some of them don't. You can write games on a Raspberry Pi if that's what you want to do. So I hope that helps for getting started.
Yeah. Eva, do you have any questions?
Is there any programs run by Raspberry Pi Foundation that encourages girls in particular to consider a tech career?
This is a huge problem, not just in programming but across engineering, and it's a really difficult one. So we have a program that's been running in Raspberry Pi to try and understand why girls don't want to become programmers, and why also in the Royal Academy why girls necessarily don't want to become engineers. And I think a large part of it is to do with image. The image of engineering. Everybody thinks that engineering is hard hats and, you know, big boots and high vis jackets, but it's not like that at all. And it's trying to get that message out that it's so varied. And one sort of program, not actually in Raspberry Pi, is a thing called This is Engineering. And you can look at that on the internet and you can see all the different aspects of engineering and what you could potentially go into. I mean, you know, it's all the way from, you know, genetics and genetic engineering all the way through to building structures, you know, real, what I call sort of the built environment, where you build bridges and you build railways and you build all that sort of thing, or even buildings and architecture. That's all has a high content of engineering now. If you go and look at a modern building, they're usually quite complex in the way that they're put together. You know, look at something like the Shard. But you know, it's important. I think that the key thing is to try and get the message out that you can. Yes, you can. You can do it. And it absolutely is something that, you know, if you want to, there should be no barriers. Unfortunately, there are barriers because people, you know, there's still this legacy where people think, oh, girl, you know, no, girls should go into nursing. Really? No, that's not. I absolutely disagree with that. You're equal, and in some cases, way better. So there was a young girl back when we started Raspberry Pi who got interested in computers and was with us at Manchester. We had this thing called a Raspberry Jam. I don't know if you've heard about those, but basically it's where a lot of people interested in Raspberry Pis and electronics and programming all sort of come together once a month to chat about things. And she went on, she started off looking at the Game of Life. Do you know that one, which is this?
When you start off and it's kind of like just like random things.
Yeah, and then there's a set of rules as to how it was. It Conway, isn't it, that created it, the Conway's Game of Life. And so she started by doing that on the computer screen. Then she did it on a little display from a Raspberry Pi. And she did loads of stuff. And I was very fortunate to catch up with her like 10 years later. And she's been doing an engineering degree. And absolutely brilliant. But there's not enough. I mean, you know, anybody who tells you that you can't do it, I just have a really bad feeling about those sort of people. You really can do it. You absolutely can. And I know people who have. And so that's why it's also important that we have role models that you can see that have done it, been there, done that, have all the T-shirts and can show you and help you down that road. There's not really a lot. It's not easy for, you know, I went to I think it was Institute of Engineering Technology dinner, and they said to me it was an awards for women in tech. They said the problem with you is you're grey, pale, stale, and male. And we don't
I've heard
really
that
want to.
saying
We don't.
before.
Yeah, we don't really want to listen to you. And that's right. We're not. I'm not the person to encourage girls into engineering. It's other girls that are already there who are actually doing it. Being an acoustics engineer for Jaguar Land Rover, being an engineer for making jet engines, being an engineer in making paint even. There's so many different engineering roles. Some of them are a little bit more sciencey, but some are real engineering. Actually making things, and they get hugely involved. So, yeah, I think, as the Nike advert says, just do it.
Yeah.
So it comes from when I went to university, I had to go and study electrical engineering because that was the only course I was allowed to do. But when I got to there, I just went to the computer science department and said, I want to do computer science. And because I was being pushy enough, they let me do it. So,
sorry.
It's all right.
My next question was how the Raspberry Pi has evolved over time and what kind of features have been added to it and like how it's been built up for every generation. And also, is there any plans for like future, like more features to be added to it, like future generations?
Well, okay. Well, working back from the so there is going to be new generations of Raspberry Pi. Otherwise, we might as well fire all the engineers that are working in Cambridge. Okay, so there has to be. But a policy that we have is we never announce something until it's ready to launch. So my lips are completely sealed on what might happen, right?
Okay.
But what we did have is we had a long list when we first started Raspberry Pi of what we'd like it to be able to do. And the plan was that we would go through that list and basically what could we afford on the first generation of Raspberry Pi. And what I was saying to Eben only a few months ago, I think now we've pretty much got everything that was on the list on to the latest Raspberry Pi. So, I mean, it's even got dual monitor, which is something that wasn't on our original list. It goes so much quicker. It's got Bluetooth, it's got Wi-Fi. They were on the original list, but way too expensive. It's got a power supply that's more efficient than the original, which is always important. Again, that's an important environmental thing, to always try and make your electronics efficient and take the least amount of power. So yeah, it's grown up and it's grown features. But it all stems back to an original list. And I was trying to think, what haven't we done? And the answer is a real-time clock. A Raspberry Pi doesn't know what time it is. When you wake up, a Raspberry Pi has no idea what time it is or what day of the week it is. A bit like me sometimes when I wake up. What day of the week? Do I have to go to work today? Yeah, I probably do. I quickly look at my phone. And the way that the Raspberry Pi gets around that is that it just looks it up on the internet. It says, what time is it? And the internet tells it what time it is. We're done.
Just like me.
What? Yeah, reach for your phone and see what.
Yeah.
Yeah, I look and see how cold is it outside. Oh, -10. Maybe I'll have another 5 minutes in this nice warm bed before I get up. Yeah. So yeah, that was that was the thing, definitely. That was so. But most other things have got there. And the most important thing, I think, is it's gone from being slightly painfully slow to being fast enough to be a practical computer that you could use day in, day out for what you want to do, for your general computing.
Does NASA or any other space agencies use Raspberry Pi?
Well, I've seen quite a few projects that have got Raspberry Pis in them. We went to a lot of trouble to make ours really sort of safe and enclosed. The boards inside it are covered in a special thing called conformal coat that stops any little bits of metal floating off the board, and then it may end up in some other piece of equipment on the ISS. But we've also seen people who've basically used a Raspberry Pi inside their satellites. I don't have any immediate names for you, I'm afraid, but I'm sure that people do use it because it works, and it's also very cheap. And that was one of the key things about it. It had to be cheap enough to risk breaking it. So you shouldn't worry about having a Raspberry Pi out on your desk and playing with it. Because if you break it, it's only $35. Yeah.
So my next question was, why was Python over every other coding, or not coding, but programming language, chosen?
Well, the Pi in Raspberry Pi was always going to be Python. But when we put PY on the logo, it looked really awful. So we changed it to PI. And that means whenever you go to things like, I was in Brazil doing presentations, and they all say about this Raspberry Pi. They don't call it Pi, they call it PI. And it's just it's the way it sort of grew. But the very original design for Raspberry Pi was going to be a bit like the old, I don't know if you know about the old BBC Micro, but basically it had, when you sort of turned it on, instead of having to get it to run, it was already there, sitting there, waiting to run a basic program. So you could instantly type something in BASIC and it would do it. Our idea initially was that we'd have this running Python and it would be there on the desk. Rather than having a desktop, it would just be there ready for you to type Python things into it and it would just run. And so Python has sort of been weaved into the story of Raspberry Pi from day one when we originally conceived of the idea. Because it's such a flexible language and you can do so much with it. And now, of course, we have Raspberry Pi Picos that run Python. So it was a good choice. But if you want things to run really quickly, then going back to some of the languages that are more established, like C, gives you better performance, but are a little bit more, how can I say, impenetrable to understand. It takes more effort to understand the language, whereas the Python's a little bit cleaner and a bit more obvious. So that's why.
I don't have any more questions for you. Eva, do you have any last questions that you would like to ask?
Yeah, I've heard that you are involved in helping startup companies. So can you tell us more about that?
Yeah, so what I suppose the sort of mantra of the company is, as I said, is bringing ideas to life and actually taking an idea and creating something with it and actually making it work. And I always find that absolutely fascinating to see people's ideas and then trying to work out how we could take that idea and make it into a physical product that they can then go on and sell. And we've done that with lots of things. One thing that we got involved with was helping a company that makes detectors that actually detect fire. And the reason that that's important is that it allowed them to deploy these in places where fire might break out. But the special feature of them is that the particular use was on an oil rig. And on an oil rig, they often have this really big flame called a flare. Okay. And what happens is that somebody walks past with something shiny on them, and the camera, the detector sees the flare. It then sets off an alarm, and they have to evacuate. So that was a false alarm that would cost, millions of pounds. So having one that is immune to the flare was a really, really good idea. And that's what they came up with. And we helped them realize that in a second generation and third generation product. We do lots of that sort of work, and it's really interesting to talk to people in different spheres of engineering and what they actually want to use the computers for. And if you look around, you'll see almost everything that you have now has got a computer in it. I suspect even if you took your kettle apart, you'd find there's a little computer chip in the bottom of the kettle controlling that. Oh, it's definitely one in the microwave. In fact, it's quite an interesting thing to go around and try and guess which things have probably got computers in them of one sort or another. But everybody thinks of a computer to have a screen, a keyboard, a mouse, but it's not like that. These embedded computers are invisible, and they just make products work.
How did the electronic design consultancy Norcott Technologies came to be?
Right. So I'll have to give you a quick sort of potted history of my life, right? So I've told you about college, and then I went to Manchester University to do a degree in electrical engineering, switched to computer science. I then became a research assistant at Manchester. I then became a lecturer in computer science at Manchester, and we had an open day. And I thought, what am I going to do for the open day? And I actually went round all the departments and tried to scavenge some bits, and actually made, and it's going to sound really, really basic now, but it was a camera system that took a monochrome image of somebody and then used this thing called false color to color them in. So it take each shade of gray would then be a different color on the screen. And so you get these really funky looking images as people walk in, depending on how their hair color. And so my little wrinkles here would come out of sort of bright blue and maybe at a green face, and my glasses might come out red. It was really quite an interesting idea, but somebody came to that and saw an opportunity to use that technology for building a machine that prints your face on t-shirts. It seems to have died out now. I very rarely see it, because now you can just send a photo to some website and they'll send you back a mat, a book, a cup, anything with your face on it. You can have any picture you like on it. You can even get credit cards that you can actually have your own picture on. It's that crazy now. But this was a long time ago, and they offered me money to go and design it for them. So that was the first chink in going from education into design consultancy for electronics. And then I built up one company, which I then sold, and that's what we used the money from that to start Norcott. So from when I left, I did a couple of years at an electronics company to learn the ropes of how it all works. And then I set up on my own, and I've been working for myself, been the owner of the companies ever since. So I'm really, if I ever had to do an interview for a job, I don't know how I'd get on, really. because I've never had to do it. I've been on the other side of it, but I've never had to do that. So probably the scariest things I get is doing interviews like this, not knowing what questions I'm going to be asked and whether I actually do know the answer. But so yeah, that's how it started. And because I love making things, I just keep doing it. So any more questions from anybody? Or have I run you out of the question list?
You've reached the end of my question list, but I'm not sure about Eva.
If you're currently the Director of Systems Engineering at Norcott Technologies, how would your typical day look like?
Right. So my typical day starts usually before breakfast, because some of my staff start at 6 o'clock in the morning. So the first thing I'll do is check the emails and see what's coming overnight, see if there's anything important that needs to be dealt with straight away. Then have breakfast and drive into the office, and then I'll have a load. On a typical day, I'll have maybe 2 or 3 meetings to organize. I'll have projects to go and talk about. So how, I'll go to talk to the engineers and see how things are going, see if we've got any roadblocks, things that we need to change to overcome them. Then talk to the production team about any issues that they've got. And then the interesting bit is when I can get, maybe an hour or two talking to customers about new projects and other ideas they've got for a new design of something. And then just sort of, I really quite like that, what call it brainstorming, to try and develop an idea from sort of a concept into, well, we could use this to do this bit, we could use this to do that bit, we could package it like this. And it's really interesting. Then what we try and do is we then try and make a prototype, because I found if I ask people what they want, it's really difficult for them to know the answer. But you give them a prototype, they'll tell you all the things they don't like about the prototype. And all those things are actually what they wanted in the first place. So getting to that sort of first concept is quite important. We had that with Raspberry Pi. I mean, the first thing that they said on Raspberry Pi was, oh yeah, could we actually push that connector down so they're all in line? And I went, oh no, there's no space behind it, so we can't do that easily. Maybe not on the prototype, but we can do it in production. And then it was, I think, two revisions later, we managed to get them all in line, and they've all been all in line ever since. But if you actually, look at my day, a lot of it, unfortunately, is pushing paperwork around and answering emails. I get rather a lot of emails in a day, but so it's a complete mix. Whereas if I was an engineer and I was working on a project, then it's very much looking for parts for the project, designing circuit boards, doing analysis of bits of the circuit to make sure they work, getting in the lab, making sure that things that we've had built actually work, designing test programs, all that sort of stuff. I love both, which is why secretly, don't tell anybody, I have a lab at home so I can do all that sort of stuff at home, so I can play with things, because that is.
What do you mean? Don't tell anyone. This is going online.
Oh no. Yeah. So that's where I get my chance to do my bits of engineering that I love. I mean, we've been very fortunate because we've built things for things like the Large Hadron Collider. So that was a fun project. And we've also built a computer that simulates the brain for Manchester University. And that's if you want to go and have a look, it was called Spinnaker, and it's absolutely huge. And I think it's a tenth of a mouse brain is all it can do. So in terms of being a human brain, it's got a way to go. But this is stuff that gets me up in the morning. Is the challenges of making all this electronics.
My question is kind of like a bit further into the future. Maybe like when you're retired, what kind of projects would you like to do outside of Raspberry Pi and your current job?
I think when I retire, if I retire, no, I mean I will at some point, obviously, but I won't stop. So I've got several things, and on my secret lab wall, I've got a robot that collects tennis balls, because I like to play tennis, but I don't like going around having to collect the balls afterwards. So what I want is this, rather than having to have people sat there, sort of at the side of the court, like you do, you see them at Wimbledon. I'm thinking, so I was watching, how fast do they pick up a tennis ball? How do they find it, pick it up? I mean, the human body is brilliant. They'll be running along and they'll just grab it as they go. Can I make a robot that can scoop up tennis balls and go fast enough to actually be useful, and then bring them back to me and get out of the way in time? So that's a little project that I've got on. So I'll always be busy, but I think I'll probably end up still doing more things with Raspberry Pi, also encouraging young people to get into engineering. I think that'll probably be my primary focus, and especially encouraging girls to get involved, because you can do it and you can be engineers and you can do it really, really well. Or being astronauts as well. It's always great to see female astronauts.
I've heard that Norcott technology also helps with educational projects. So can you know more about that?
Yeah, so what we do is, wherever we can, we get involved in two ways. One is that just in the last couple of weeks, we were helping out some students at Lancaster University that needed some kit for their project. We also get involved with gap year students, that have not exactly a gap, it's a sandwich, what they call it, a sandwich course, where they'd work for a year in industry. Then also over the summer jobs, and also, the people who come on, work experience, I think they call it, where they come for a couple of weeks and actually work with us and understand what goes on. Because it's crucially important that if you can't be something you've never seen, you can't really, if you never saw motor racing, then nobody'd ever want to be a racing driver. If nobody had ever seen an aeroplane, nobody would want to be a pilot. But what you never see is the person who takes the jet engine apart and puts it back together again to make sure it's safe to fly, because they're never visible. A lot of engineering is invisible to general society, and we've got to change that. So I think, when I retire, I'll definitely be doing a lot more of that. But while I can, we like to help students wherever we can to be involved and help them out if they need things.
I have heard that during your career, you've developed more than 100 electronic products. So, can you tell us about it?
Right. Okay. So this is where it gets a little bit tricky, okay? Because we design products for other companies, and those companies do not necessarily want to know that people to know that they contract out the development to people like us. So and there's a thing, I don't know whether you've heard of it, it's called a non-disclosure agreement. Yeah. And we say we promise not to talk about this project Yeah. So it's really difficult for me to talk about that, but it's slightly more than 100 now. It's I mean, ones I've done directly are probably 250, 300 projects, but now I've sort of moved position to as a director. Then I've got people designing projects every week for various pieces of equipment, and it's such a wide range of things that we do. So yeah, sorry about that. That's really a bit of a tricky one.
I was wondering maybe if you could, like, when you face issues with developing products, how do you kind of overcome those? And like, what's like kind of like the process of like testing for bugs and like issues to find them before you release not just like Raspberry Pi, but also like other products that you make for other companies?
Right. Okay. So there are a number of issues in developing products, and you can use bits of circuits that you think are going to be okay because you've used them before, but sometimes you really do have to break out into new territory and you're not sure whether it's going to work. And so in that environment, you can get yourself stuck and you can be sort of beating your head against a brick wall trying to get through a problem. And what I always say now is that what we need to do is we need to step back from that wall that we're hitting our head against and try and figure out how wide it is, because it might only be 6 feet wide and we could actually step back and walk around it. The problem you get is that you invest in a problem. You spend so much time trying to fix a problem, then backing out and saying, okay, we're not going to fix this, let's go a different way, is a really hard thing to do. But it's actually a very successful thing to do. Often that is the way to fix. We might be working with a chip and it really doesn't work. And the chip doesn't do quite what maybe the data sheet implied it did do. The right thing is potentially change that chip and go for something else that does work, rather than just continually beating your head up against brick walls going, but in order to solve problems, you've got to figure out what the problem is. Often you see the symptom, but not the problem. And one of the ways I do it in when it gets really difficult, I make a list of all the things I think it could be, and then go through the list trying to prove that it's either that or it isn't that, trying to find a way of maybe writing some code or developing some circuitry or doing some testing. Or can I prove it's this? Can I prove it's that? And usually what happens is I end up crossing out the whole list and get left with nothing and go, that's a problem. So then you've got to think of some other things that you can try. What it's all about is to gain information. You do tests that gives you information, that gives you a clue. And it's almost like, it's like almost like a murder mystery in some cases. You're trying to find clues to the problem that when you can get all of them together and put them, you say, I know who did it.
That's a really good analogy.
It was that chip there. He did it. It's his fault. He sent the wrong signal, and that's why it all doesn't work. So if you want to be a detective, go into electronics. Yeah. Because trying to make electronics work sometimes is really detective work. But you also need patience of a saint, because it can be very frustrating. But when you get it working, it's, that is the high point. So that is definitely the thing, because then, everybody's around the office high-fiving, especially if we've spent weeks on it. But so it's breaking the problem down into the smallest section you can, trying to narrow it down to the smallest part of the circuit that might be going wrong, and then getting involved in it and fixing it. and then being frustrated by the fact that it was actually something really, really, really simple that you just couldn't see because you've been working on it. And that's where colleagues come in. The number of times that people have walked into my office and said, I've got this problem, and I go, right, tell me about the problem. They're talking about it, they're describing the detail, and halfway through you can just see this little light bulb light up on the top of the head. Right, okay, thanks. And they go away. They don't tell me what the answer is. They just go away. Because talking about it and actually discussing it, the brain sort of does something different with it. And suddenly all the pieces slot together. Yes, of course. It's obvious. It's that. And they go and try it and it is. Or they come back because it isn't. And we just talk about it more. And I do that. If I have a problem with something, I'll go and talk to one of engineers. I'll say, just want to talk to you about this. And then they go, oh, have you tried this? Or have you tried that? And this is where collaboration is really important. Don't go it alone, collaborate. It's teamwork. And having a really diverse team of people means that you're going to get opinions from all different directions. And one of those directions might help to give you a clue as to what the problem is. There are problems that I've never fixed, I have to say, and I've just had to sort of give up on them. But it happens from time to time, and the solution is to change the chip, put something else on, and solve the problem for the customer in a different way.
I've heard that your career started when you were 13, and that's pretty impressive. So what's your message to children who are interested in engineering?
Again, I think that my message is just get involved. Probably don't take the back off the television like I did and to see how it works. Just ask permission first. But there's plenty of old electronics out there that you could get hold of and take apart and have a look. I mean, I know somebody who got into clockmaking, and he said the problem I always had, he said, I took the clock apart, I put it back together, and then I was left with 4 or 5 bits that I didn't know where they went. And eventually you learn how to make a bit more of a record of how you took it apart. So when you put it back together, you put it all in the same places. But it's really difficult with some because like your phone is all glued together. You can't get in easily to see how it works and have a little bit of look and a tinker with it. But that's where it starts. It starts with tinkering and doing things that interest you. And, you know, if you want to make something, then say, I want to make this and figure out how to do it and then try and get the bits. But what you need most of all is encouragement, because it can be, you know, you can get to a point like I talk about this journey, you get to a thing that's really difficult. So if your parents can help or grandparents or friends who are interested in it, that all helps to sort of keep you interested in trying to get to the result. I always find it's easier if there's 2 of you or 3 of you rather than just one person doing it. But it is really just, if you're interested in it, get involved, try and get teachers involved. Physics teachers are usually a really good target because they're usually quite practical and quite interested in bits of electronics and things, or there might even be an electronics club or an engineering club at the school. You just have to ask and try and find out. Or if you're really interested in coding and things, try and find a code club or a coder dojo or a thing called a makerspace. They're quite interesting because they exist where people come together to help each other make things. So how are we doing?
Eva, do you have any last questions?
You had a really long list. You've been doing some good research there.
Will the Raspberry Pi ever increase in price with inflation?
Inflation, that's very topical at the moment, isn't it? We have a lot of yeah. So there are two things that work with inflation, and the first thing is the more you make, generally the cheaper things become, because the parts that I mean, you know that it's like almost like the Tesco 2-for-1 offer, buy 3 and it's this price. Or you go to a wholesaler and buy 100, it's quite a lot cheaper. Or then you go to another wholesaler and buy 1,000, the cheaper still. And so as we've grown, the component cost has got cheaper. But what we've done is we've then reinvested that by putting more electronics on the product. So if you look at the original one, I don't know whether this will work terribly well, but you look at the original one and you look at the new one. Oh, sorry, it's getting the right height. You'll see there's quite a bit more on this than there is on the original. And what we've added features. We've added new parts to the product, but we've tried to keep the price the same. Now, in the later years, we tried to keep the base price the same, and then things that have got a lot more features or a lot more memory have been more expensive. So the idea has always been to try and keep the base Raspberry Pi at $35, but that's not something we can always guarantee, because it depends on the price of the chips, it depends on the cost of labor. So I guess at some point it may be that we're going to have to break with our 10-year tradition of being $35, and it may have to become more. I mean, one of the things that obviously has an influence is the exchange rate. So how much a Raspberry Pi will cost you in the UK may be more if our exchange rate to the dollar changes, or it may be less. Yeah. So there is something always to think about there. And the reason it's priced in dollars is simply that all the components we buy to put on a Raspberry Pi are all priced in dollars. That's the universal currency of semiconductors, is dollars. So that's why.
So I think this might be our final question. What would be your main message to the next generation of engineers and kind of, coders and programmers?
I think, well, my message would be, it seems that the current generation, and to some extent my generation, have made a bit of a mess of the planet.
Yeah.
Right? And I think, sadly, whatever we wish had happened, somebody else always had the phrase, we are where we are. But I think engineering can make the world a better place. It can help society. It can do all, like medical robotics, where it can operate on people quicker and more efficiently. It's hugely important because it improves quality of life. But also, like I say, the engineering can also help to change the planet by helping us get away from fossil fuels and get onto renewable energy. I mean, just this week, there was this major breakthrough, wasn't there? Did you see that with fusion energy? Actually got more energy out of the fusion reaction than they put in for the first time.
Yeah, I saw about that.
So
was that in America?
That was in America at Lawrence Livermore. I mean, that is a project. I mean, people have worked on that project for their whole lifetime to try and because if we can crack that problem, then we get an unlimited supply of energy. And that, if you think about it, in a moment, that would massively help where we are with the climate and the planet. But we can do small things, which is design things that are more efficient, design insulation and design buildings that don't need as much power, design more efficient solar systems that can collect power from the sun. there's lots of engineering that we can do to make the planet a better place. And it's really trying to force governments and things to actually say, you need to do this. Don't sit around. We need to invest in engineering to make these things happen. So that'd be my message, that if you want to make the world a better place, then engineering is a great place to start. And having the skills of an engineer in whatever discipline of engineering that you choose.
Thank you very much for letting us interview you today. It's been really interesting.
Oh, you're welcome. It's always a pleasure to talk to, hopefully, two budding engineers. I'll see whether I can convince you. I'll be looking out for you and making sure that, I'll see that you go to university maybe and study engineering. Is that something that you, what do you fancy doing at the moment, Emily? What's your passion?
To be honest,
don't know yet.
I used to be interested in AI, but I'm kind of a little bit wary of it now. I think it's a bit of like a worry, like because I know it can be useful, but it's quite a worrying thing as well. Because like with like certain things, it's just
it's all a bit spooky,
well,
in places.
Yeah, so it's like, with like AI art and that kind of thing, and it's like where they're kind of replacing a lot of the human workers and like putting people out of their jobs to find a cheaper solution for things. It's quite scary.
Yeah, computers have always been good at that. If you look back in the history of computers, they've made people who were sat there with thousands of calculators calculating numbers. They actually also replaced. Do you see the film Hidden Figures? The people, those ladies who computed all those trajectories and things. Computers have replaced what they do. But hopefully what it does is it allows them to have the time and the space to think of something even better and to build on that technology and use it. And yeah, AI is a worry, but it's here. It isn't going to go away. So what we've got to do is find other things that humans are better than AI at. And to be honest with you, I wouldn't worry just yet, because AI, I've often said that AI should be called AS, which is artificial stupidity, because it makes mistakes that a human would never make, because we have so much context to our environment, and the human brain is a very clever engine, and understanding that would probably make AI better. But the best way I would have said, not to be worried about it, is to be involved in it, so you understand it, and that gives you a better scope of what it is capable of doing. You might then be worried. I don't know. We all worry about the Terminator and all those sorts of things in the movies, but I think it has enormous power to do good. It has the capability to do good. We just have to harness it in the right way. What about you, Eva? What's your thoughts?
Well, I want to be an astronaut.
Well, that's fabulous. And why not? That's a very laudable aim. You fancy it on a mission to Mars?
Yeah.
And why not? That'd be good. So I'll be looking for your name on the first roster for the Mars missions then. That'd be good. Okay, look, it's been brilliant to talk to you. Thanks for all the questions, and
thank you for answering them.
No, you're welcome. Okay, take care, everybody. Bye for now.
Take care.
Bye.
Yeah.